Hey guys, Mr. B here. In this video, we're going to be going over the precipitation reactions worksheet. I don't know if I'll be going through this entire thing, but I'll probably at least go through questions, maybe numbers 1 through 4, and maybe I'll leave numbers 5 and 6 for you to do on your own. Hopefully this will help you. All right, so for each of these, we are dealing with double replacement reactions. We're going to have to be using our periodic table and our solubility chart. So you're definitely going to want to have your periodic table available. We're going to be using this part here on the back upper right hand corner. If you don't have your periodic table on hand, make sure you go get it right now before you start doing this. So, all right, so we have these reactants. And I guess we should probably check to make sure that they're aqueous, but I'm going to assume that they're all aqueous. Otherwise, they wouldn't be giving them to us. So we're going to write out our balanced, we're going to write out our products. We're going to balance this equation. Then we'll write the complete ionic and the net ionic. All right, so double replacement, we have a lithium carbonate reacting with cobalt 2 acetate, or just cobalt acetate. So in our products, let's do this in red actually. Our lithium is going to bond with the acetate. So let's actually zoom in as well. All right, so here's going to be one product. Okay, so the lithium and the acetate are going to bond together. And again, just in case we don't remember formulas and how to do charges, lithium makes a charge of +1. Acetate is a polyatomic ion, has a chemical formula of C2H3O2 and a charge of -1. So when these two bond together, this is the chemical formula that they make. Okay, so that's going to be one product. The other product will be cobalt bonded with carbonate. Cobalt makes a charge of positive, or in this case it's cobalt 2. Okay, there's a 2 here, and that is because we have a cobalt ion, which has a charge of, that's not what I meant to do, has a charge of question mark, okay, something, we don't know what it is, but it's bonded with acetate, which has a set charge that is -1, okay, and there are 2 of them here, so that means that there are 2 of these ions, so total, this is going to be -2, which means the cobalt has to be a +2, okay, that's how I know it's cobalt 2. And so when the cobalt bonds with the carbonates, cobalt is Cu2+, carbonate is CO3 2-. So those would be the same charge. They balance out in a 1-to-1 ratio. And here are our 2 products. All right, from here, we're going to have to check to see if either of them will be a solid. Okay, one of them needs to be a solid. They can't both be aqueous. So the first one here we have is lithium acetate. So let's check this one first. So we're going to pull up our periodic table again. We're going to look on the back. Let's find lithium, which is here. Acetate is here. And we see that that is aqueous. All right, so that one is not a solid. So hopefully the other one is going to be. But we're going to mark this then as AQ for aqueous. This is cobalt 2 carbonate. So let's check this one and see if this one is a solid. So we have cobalt 2 right here, and we had cobalt 2 carbonate. That's carbonate right there, and we see S for solid. All right, beautiful. So that one is a solid, which is good. So let's go back to our sheet. Mark this as S for solid. All right. So from here, we need to balance the reaction. It looks like our lithiums, we have 2 on the left, we have 1 on the right. We're going to need to put a 2 there to balance out the lithiums, and let's maybe just do this in a different color. There we go. So there's 2 lithiums. That also is going to give us 2 acetates, okay? The C2H3O2, keep that as a chunk. That's a polyatomic ion. So there are 2 of them, and on the reactant side, there are 2 of them. So that balances out. And then we have 1 carbonate ion. So we have 1 CO3. Again, we'll keep that as a chunk. It's a polyatomic ion. On the product side, we have 1 CO3. And then we have 1 cobalt atom here and 1 cobalt there. So balancing wise, all we need to do is put a 2 in front of that first compound. And then everything else is good. All right, so let's, I guess I'll leave that there, whatever. Okay, so writing our complete balanced ionic equation. Anything that is aqueous, we're going to break apart. we can assume that all of these things are aqueous. And in fact, probably on your sheet, it'll say aqueous. I'll change it. So these are all going to be aqueous, which means that anything that is aqueous, we are going to write as separate ions, and anything that is not, we're going to keep together. Okay. So we have 2 lithium ions, which are aqueous. And again, you'll notice here that I'm writing a big 2 out front and not a little 2 down below. And the reason why is this. When it is bonded together with the carbonate, those 2 lithiums are bonded together. So that little 2 means that those are together. Okay. But once they're in water, those 2 lithiums are floating around as individual ions. They're no longer bonded together anymore. So the big 2 shows that we have 2 of them, but they are separate, not together, okay, as like a molecule. So we have 2 lithium ions. We have 1. What did I do there? 2. There we go. We have 2 carbonate ions. I'm sorry, one carbonate ion. We have a cobalt 2+ ion, and we have an acetate ion. 2 of them actually. Sorry, we have two of those. Okay, so something like that. All right, so that is our reactant side. On the products, this is aqueous here, so we need to write this as separate ions. So again, we have our 2 lithium ions that are aqueous. We have our 2 acetate ions. Oh, that did not go out the way I want to. C2H3O2 minus AQ. All right. And then the cobalt carbonate, which is a solid, that will remain a solid. So we're going to keep that as it is. Okay. So here's our balanced our balanced complete ionic equation. And then our net ionic equation is going to be this thing here minus the spectator. So I'm just going to copy and paste it. And then we're just going to remove the spectators. So on both sides, the things that are exactly the same, we have 2 lithium ions that are the same. So that's those 2. And we have 2 acetate ions, which are the same. So that are these 2. So we're just going to get rid of those. So let's get rid of that like that. Let's get rid of this. And then we'll get rid of all this. And bam, that's what we got. Now, if we want to, we can put the cobalt ion first, and the carbonate ion second, I guess. But it's completely up to you. You can leave it as it is. I'm just going to rearrange it. Typically, you write the positive thing first and the negative thing second, so I'm just going to rearrange it. But all right, there's our balanced net equation, and that's it for this one. That's all we got to do. So. All right, moving on to the next one here. This is going to be aqueous. This is going to be aqueous. All right, so again, another double replacement reaction. So let's write out our products. We have iron 3. Okay, this is going to be iron. And iron can make +2 or +3 ions. So I guess technically we don't know what it is. I do know it is an iron 3 ion, and here's how I know. It's bonded with nitrate, which is NO3-, and there are 3 of them. Okay, so there's 3 of them. So each one is -1. That's a total of -3. There's only 1 iron in this compound, so that 1 iron has to be a +3 to balance them out. Okay, that's how I know it's 3+. So it's iron 3+. We have potassium ions here bonded with a sulfide ion. So when these things switch with each other, the iron is going to pair with the sulfur. So we'll have a chemical formula that'll look like this. And we will have the potassium bonded with the nitrate, which will have a chemical formula like that. Okay, so these are our 2 products. Again, we need to go check to make sure that one of these is a solid. So let's go look on the back of our periodic table. We have iron 3 sulfide. Okay, that's the first one. So iron 3 sulfide. Let's go check this. So iron 3 is here. Sulfide is here. If we go and check this, now it has this little dashed line. That means that it's partially soluble. basically it just means that some of it dissolves but not all of it. So we're going to count this as a solid. Okay, we have we have Fe2S3, so this is going to be a solid. Again, this is partially soluble, so that will count as being a solid. Some things fully dissolve in water and being soluble. Some things don't fully dissolve, so they're insoluble. And then we have like some things that are partially soluble. This is partially soluble, but we're going to count it as being a solid because some of it will be there. And then we have KNO3, so that is potassium nitrate. Let's go check that one also on our periodic table to see what that one is. Most likely it's going to be aqueous because we already have our solid, but here's potassium, here's nitrate, and we see that it is KNO3, and that is aqueous. Beautiful. All right, so we can go mark that on our sheet, and we know that this one is going to be aqueous, which is perfect because we shouldn't have two solids. All right, so here's our equation. We got to balance it now. So we have two ions on the right side. We only have one on the left. So let's put a 2 there. That'll balance out the ions. That also now gives us 6 nitrates. Okay, we have 2 times 3, that's 6. On the right, we only have 1. So we're going to need to put a 6 there to give us 6 nitrates. That will now give us 6 potassiums here on the right. On the left, we only had 2. So we're going to put a 3 in front to give us 6, right? 3 times 2 is 6. That balances these. And then this 3 will multiply the sulfur to be 3 sulfurs, but we have 3 sulfurs right there. So that works out. There's our balanced equation. So now let's write our complete ionic equation. Again, anything that's aqueous, we're going to write as separate ions. So we have 2 Fe 3 plus ions that are bonded with 6 NO3 minus ions. Okay, now again, just to make sure we understand, there are 3 ions here times 2 there. That gives us a total of 6 of them. Okay, and each one is, again, a separate nitrate. Okay, the separate nitrate floating around in water. There just happen to be 6 of them, so that's why we have a big 6 out front. Okay, all right. Then we have 6 K plus ions. Again, we have 3 times 2, that's 6, plus 3 sulfide ions, which are aqueous. Okay, so this is our reactant side. Here's everything on our reactant side. On our product side, we have the Fe2S3, which is a solid, so we're going to write that as it is. And then this is aqueous, so these are going to be written as separate ions, just like they were before. And 6 NO3 minus ions. All right, so this is our complete ionic equation. Let's copy this. Let's paste it. Let's figure out our spectator ions, delete them, and then we'll have our net ionic equation. So it looks like on the both the reactant side and the product side, we have these 6 NO3 minus and 6 K pluses. We have them in both places, so we're going to delete those. So let's get rid of them, and let's get rid of those there. And there we go. This is our balanced net ionic equation. Okay? All right. Moving on to number 3. That's aqueous, and this is aqueous. All right. So we have here lead 2 nitrate. Okay, this is Pb 2 plus with NO3 minus. And we have lithium sulfates. This is Li plus with SO4 2 minus. This is going to be double replacement. So the lead 2 is going to bond with the sulfate. So we'll get PbSO4. And the lithium will bond with the nitrate. So we'll get LiNO3. And then we need to go check to see if these are going to be aqueous or not. So let's go back to our chart. We have lead 2 sulfate is one of them. So let's check that one. So lead 2 is here. Sulfate is here. And we see that that is a solid, so that is perfect. So one of these ones is already a solid, so let's go mark that on our sheet. So this one is a solid. As for the lithium nitrate, we pretty much can then already figure out that it's probably going to be aqueous, but we'll check it anyway. So we have lithium here, nitrate here, and this is aqueous. All right, so that one is aqueous. So let's go mark that one as aqueous. AQ. Okay, so these are our products. One of them is a solid. That's great, which means we are definitely going to have a reaction here. And we need to balance now. So it looks like the leads, we have 1 and 1. Those are balanced. Nitrate, we have 2 on the reactant side. We only have 1 on the product side. So we're going to need to put a 2 in front of this compound. So that'll give us 2 nitrates. That now gives us 2 lithiums. But we have 2 lithiums on the reactant side, so that balances out. And then we have 1 SO4 here, and we have 1 SO4 there. So there's our balanced reaction. Let's move on to doing our complete ionic. Again, anything that is aqueous, we are going to write as separate ions. So we'll do this out real quick. AQ plus 2 lithium ions for aqueous, and a sulfate ion, which is aqueous. All right, so here is, oh, this should be a capital O, apologize. So here is our, here's everything written out as separate ions, that's aqueous. On the product side, the PbSO4 is going to stay as a solid because it's not aqueous. And then the LiNO3, the lithium nitrate, is going to be written out as separate ions because it is aqueous. So okay, so here is our complete ionic equation. Everything should be balanced out. We're going to copy paste this to our net ionic, and then we'll find our spectators. So it looks like we have 2 NO3 minus and 2 Li plus on both sides. So that's good. Those are going to be our spectator ions. So let's delete those. Let's delete them, and bam, there is our net ionic equation. All right, last one here we're going to look at is number 4. Like I said, I'm going to leave number 5 and number 6 for you to do. And if you really need help with them when you get there, let me know. But hopefully just by looking at these 3, this will help you figure out the rest of them. So, all right, number 4, we have ammonium chloride. So this is NH4. Oh, why did my font change? I don't like that. I want my normal font. There we go. So you have NH4 plus. That's ammonium, okay, that's polyatomic ion, bonded with chlorine or chloride. Then we have copper, and this is going to be copper 2 plus, bonded with acetate, which is a polyatomic ion. So that has a chemical formula of C2H3O2 minus. Okay, I know that this is copper 2 plus because there's 2 acetates. So there are 2 of these, which means total they are -2. That means that this copper has to be +2. Okay, that's how I know that's copper 2 plus. So double replacement, we're going to have the NH4. Why does it keep changing my font? Stop it. We're going to have NH4 bonded with C2H3O2. Okay, so there's one product. That's our ammonium acetate. And then the copper 2 is going to be bonded with the chloride. So it's going to look like this. All right, so now that we have our 2 products, let's go check to see if either of them will be a solid. Because if not, then this reaction is not going to happen. So we have ammonium acetate as one product. So let's see, we have ammonium here, acetate. Okay, so that is aqueous. All right, so we're going to go mark that. So this one here is aqueous. All right, then hopefully the copper 2 chloride will not be aqueous. Let's find out though. So let's again go back to our chart. We have copper 2, so copper 2 chloride, and this says aqueous as well. All right, so this is the first one now that we've hit where they are both aqueous. So we get to this point, and you might go, okay, so then now what? Well, this basically just means there's no reaction. Okay, so we just wrote all this stuff out for basically no reason. So no reaction. Okay, so sometimes, you know, that's how it goes. You write out all this stuff and then you go check it and you realize none of it happens, so there's no reaction, which means what do we do for the balanced complete ionic? Nothing, because there's no reaction. And what do we do for the net ionic? Nothing. There's no reaction. Okay? All right. So for number 4, pretty easy one, because there's no reaction takes place. All right, so number 5 and number 6, again, I'm going to leave those for you to do. Hopefully these ones here will help you. And again, if you're still confused, by all means, please reach out to me. I have no problem sitting down and working with you. All right, guys, that is it for this one, and I'll see you in the next video. Bye.